All right, you guys ready? You guys ready? All right, so
Yeah.
class.
Yes.
All right, wonderful day for us to do some math. Now, I will let you know, this class, this entire year, there's 3 things you need to know to be successful. And that's why I teach this way. You need to know X, you need to know Y, and you need to know R. Those 3 things. In every single right triangle, there is an X, Y, and R. Every single formula in trigonometry is based on X, Y, and R. Everything that we're going to do for this entire year is based on X, Y, and R. So, there are some things that I'm really going to ask for you guys to try to memorize because you're going to use it that much. So, you're going to need X, Y, and R, but you can't text it to people because you have to be in class paying attention right now, right? Anyway, so X, Y, and R, that's the basis of everything. So as I go through and teach this, I'm going to teach it as X, Y, and R for everything. A lot of stuff that we do, they overcomplicate all the math. They try to make trigonometry hard. It's not. 3 things you have to know, and I've been teaching this long enough that everyone that shows up to class actually passes. Everyone that does the work passes. Everyone. Because it is that easy that it's X, Y, and R for everything. And the sooner you guys get a hold of that and clamp onto that in your brain, X, Y, and R, you're good. So, we're going to start with this today. So, in my right triangle, if you notice, we have an X right here. We have a Y, and then the R is going to be from the origin of my coordinate plane or my Cartesian plane out to whichever point that I'm going to go to. So, if I'm looking at this as a right triangle, how would I find the R value in a right triangle? Starts with pi, ends in Pythagorean theorem. Pythagorean theorem, right? We're going to use Pythagorean theorem so often, you're going to be able to look at these problems and say, hey, my answer is this. We're going to use it that much. And that's the way I teach this, because why teach 40 different ways when you could do it one simple way every time? So that's my method of teaching. So X, Y, and R for all these things. So to get R, we're going to have Pythagorean theorem. My normal Pythagorean theorem is a squared plus b squared equals c squared, right? Say yes. Okay, and c would always be the hypotenuse of my triangle, right? It's always the hypotenuse of the triangle. It's always the longest side of my triangle. It's always opposite the right angle of my triangle. We're just going to take that formula and just apply it to what we're doing here. So A is going to be my x direction. B is my y direction. C is the radius of this. Because once I actually try to do this as a unit circle, you'll see that it is going to be the radius like that of a circle. So it's from the origin out to some point would be the radius. And that's where we get the R value. There we go. Make sense?
Yeah.
Yeah. Está muy fácil. Now, here is the 6 trigonometric functions that we're going to use. These are the ones that I'm going to tell you that you're going to need to try to memorize. Sine is always the y over r. Always y over r. So I'm going to go back and I'm going to show you from here. So if this is my reference angle right here, do you guys remember how to figure out sine, cosine, tangent? You guys remember that, kind of?
No.
Kind of. All right, you guys ready? You guys are going to write this down in the notes part right here. Okay, you're going to write this down right here. So it doesn't have to be right here, but somewhere on your lines, because I don't have lines like you guys have. So you're going to write sum old hippie caught another hippie tripping on acid.
Oh, that's wild, bro. This is something so important.
It is, but, okay, it's a mnemonic. It's actually a funny phrase that makes you remember it. Some old hippie caught another hippie tripping on acid, right? So, we're going to write it as such. So there's the whole thing, but now I'm going to abbreviate it to make it a little bit easier. So some old hippie, so that represents sine. So what is sine supposed to be? Sine is opposite over hypotenuse.
Yeah, I caught that.
There you go. Then the next one's going to be some old hippie, then it's caught another hippie. So my cosine is adjacent over hypotenuse, right? And my last one is tripping on acid, where my tangent is opposite over adjacent. So I abbreviate it like this, but that's the phrase. That's the phrase that goes along with this, so we could actually remember this every time. Now, for here, these are the locations of these things. Now, if I had my right triangle, which I'm going to draw one, let's draw one right here. There's a right triangle. Okay, here's my origin. Here's my reference angle. So from here, this side would be my y value, my x value, and my r value. So that blue angle right there is my reference angle. So sine. So that's some old hippie. So from my blue angle, opposite of my reference angle here is going to be what? What value? It's the y, isn't it? Yeah? So from here, the y value is my opposite, but what is my hypotenuse?
R.
So that's why sine is y over r. Cosine is going to be adjacent over hypotenuse, right? So from my blue angle right here, adjacent would be the x value, right? X value, and my hypotenuse is the r. And that's where I get x over r. Next one's going to be tangent theta. Tangent is tripping on acid, right? So opposite over adjacent. So opposite of my blue angle right here, opposite the blue would be the y value. And my adjacent here is the x. So that's why it's y over x. Now, these other things are called the reciprocal identities. What's the word reciprocal mean? What does reciprocal mean? Reciprocal. Yeah, there it is. Flip it over. Reciprocal means flip it over.
Oh.
No, seriously, that's it. Reciprocal. In math, that means flip it over. So let's see. So the reciprocal identity for sine is cosecant. And it's, I take my sine and do what? Flip it over. So instead of y over r, it's now r over y. And why can y not be 0?
Because it's canceled.
Because it's what?
Canceled?
No. Think about fractions. Can you have a 0 in the bottom? No. You cannot divide by 0. That's why this would be undefined. You cannot have a 0 on the bottom of fraction. Cannot divide by 0. So that's why that says that. Secant is the reciprocal of cosine. Cosine is x over r. Secant is r over x. Same thing, can't have 0 on the bottom. Cotangent is reciprocal of tangent. So it becomes x over y. And now this time y cannot be 0. So you're going to use this slide a lot. So for this example, it says the terminal side of angle theta, which is here. Angle theta, the terminal side would mean that the angle starts at the bottom and goes up this way. So terminal means it ends, is going to be the position of 815, right there. So my ordered pair is always in alphabetical order. It's always going to be x comma y. So my x value is 8, so that means it goes to the right 8. My y value is 15, it goes up 15. Find the values of the 6 trigonometric functions. Now, what am I missing here? I have my x, I have my y,
Your radius.
I gotta find my radius, right? Let's do that. Now, I'm gonna go through and find that. So it's gonna be, there was a formula, and that was r equals the square root of x squared plus y squared. Now, I'm gonna show you where that comes from. You don't have to do it like this every time. I just wanna show you where this information comes from. We said that x squared plus y squared equals r squared, right? Say yes. This is my Pythagorean theorem. And I want to get my r by itself. How do you undo a square? Square root, right? So I'm going to square root. But when I do this, I'm going to square root both sides. So now it's going to look like this. But when I do this, what can I not forget about?
The square root of the.
There's something special I can't forget. So whenever you square root, Doctor? Hey, this one says you did not give them their planners.
Exactly what I'm gonna go do right now.
I gave this one, so if you could just give me back, because for one of my advisory kids that.
I'll drop it off.
Okay, thank you.
You're responsible for giving me one anyway.
Plus or minus? Plus or minus, because there's two possible answers. Plus or minus. It's plus or minus. There's a possibility because this, watch this. So if I were to plug this back in and I square a value, so if I say r is equal to plus or minus 5, that could mean that r squared would have been -5. Wait, that would be 25. There we go. Make it a little bit easier. Crap. Okay. R equals plus or minus 5. There we go. Okay, try it again. So when I did this, it would be the square root. So r equals. Now, I'm going to do it this way now. R come on. R equals. So to get back to my square root of 25 here, if I square 5, what do I get? What's 5 squared? 25. What if I square -5?
Also 25.
So -5.
It's going to be also right there. So there's a possibility, because if you square the negative, it will also become positive 25. So at this step right here, you cannot forget that there is going to be a plus or minus all the time. This is going to be key for a lot of the problems we're going to do, that you're going to have a plus or minus. We don't have it on this problem, but I'm trying to show you that there is a reason for it. Now, I said that R is the radius of a circle, right? Say yes.
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 R is the radius of a circle. Now, the properties of this says that a radius is always positive. Have you ever seen a negative radius? No. I've seen a negative Diego, but never a negative radius. Come on, I'm trying here. Anyway, so this one is always going to be a positive. So radius is always positive. The radius is always positive. So let's try it again. Okay, you guys repeat after me. The radius is always positive.
The radius is always positive.
Because the radius is always we know that the radius must be, because I cannot have a negative radius. It's a distance. I cannot have a negative distance here. So when I do this, I get simplified as R is equal to the square root of x squared plus y squared. That's where that all comes from. Again, you don't have to do this, all the steps every time, but I wanted to explain to you because we're going to have to deal with this. The plus and minuses, the positive or negatives, all those good things. So we're going to plug in my values. I'm going to plug in the values here now, okay? So you guys got extra lines. I don't have extra lines, so I have to try and replace what I got. So R is equal to the square root of x, which is 8 squared plus 15 squared. Squared, there we go. Let's go ahead, do those. So that's going to be R equals the square root of, what is 8 times 8?
64.
Very good, 64. Plus, what is 15 times 15?
That.
225? Hopefully. Okay, and what are we going to do with those two values?
Add them.
Add them?
Is it?
Yeah.
Yeah.
Okay.
Why
We're
you
supposed
meant
to
that,
add
you didn't say it?
So we get R is equal to the square root of what? 2 what?
89.
And what is the square root of 289?
Tell you.
You don't have to know it off the top of your head.
What is it?
You have calculators.
17. Or even is that character?
That's square root.
Oh, that's
right above it, so
Square root is way?
and so 2,
God, nine.
right?
What? Oh, see that.
There we go. 2 radians, right? Okay.
17.
All right, it's going to be 17. So, let me show you. Okay, so square root first. So control. And here, I'll put it on the calculator so you guys can see. All right, so right here, so it's going to be control x squared right here. That's going to open up my bracket, and you put 289, hit enter. Now, there's also this thing up here. If you notice right here next to the book, that's a bunch of the different things you could use also. So if you get lost, you're like, I don't know where it is. There's the book, and the one to the left of the book has all the different setups. Okay? So like cube root, you would use this one. Alright. So, there we go. We get that as 17. So now it's asking for the 6. So again, we know, what was my x value?
For the last problem?
Yeah.
8.
8, very good. y equals,
15,
and r is,
17.
so I want you to write this on, every time you do this, write these down. Write these down. Write down the x, y, and r, because I said the three things you will need all the time is your x, your y, and your r. Every time, x, y, and r. So please write down your x, y, and r, because every time you do one of these problems, you're going to need to do all 6 of them. Okay? And so as long as you have them listed there, x, y, and r. So let's see. So sine is y over r. So what is that going to be? Very good, 15 over 17. Cosine is x over r, which is? Tangent is y over x, and that comes out to be?
15 over 8.
There you go, right? 15 over 8. Cosecant is r over y. Remember, that's the reciprocal of sine. So that's going to be?
17 over 50.
Very good. Secant is?
17 over 8.
Very good. And cotangent?
8 over 50.
8 over
Fitting? 8 over fitting. Good job. Fitting. Fitting. All right. You guys feel pretty good about this?
Yes.
Yeah, this is actually pretty simple as we go through. It just gets easier from here, because these 3 things are going to be the key to the entire year of this class. Example 2. So we're going to do this one. Today's Tuesday, right?
No.
52. Yeah. So terminal side of angle theta, which we have here, is at -3, -4. So here's my reference. Okay. So the 3 things I need for this problem are my x, the y, and the r. Am I missing anything here? I'm missing the r, right? I have the x, which is -3. I have the y, which is -4. I just need to find my r value. So let's go ahead and plug that in for my radius. R equals the square root of, and as you're doing this, a lot of people struggle with this, like staying awake during my class because I'm just that boring. Dude, do you need some coffee or something? I got coffee back there. You want it? You sure? No? Good? Okay. So, parentheses, -3 squared plus -4 squared. If you notice, I put these in parentheses. If you don't put it in the parentheses, then you're going to have a bad time. Okay? Don't do that. So if you put it in parentheses, you will remember that you always have to include the negative when you square these. So -3 times -3, what is -3 times -3?
9.
9, positive 9, right? 2 negatives will make a positive, so it's 9 plus -4 times -4,
16.
positive 16. 9 plus 16,
25.
and square root of 25 is?
5.
There we go. So now, do I now know my x, y, and r?
Yes.
Okay. And we're going to find all 6 of these functions. So we have this right here. Sine, so my x value, what did we say x was?
3.
-3, right? The y value is?
-4.
-4, very good. And my r value is?
5.
5, good job.
I thought you couldn't have that.
Now, here's the key. What do we know about the r value?
It's 5.
It's always,
Positive.
r value is always?
Positive.
So when I'm doing a fraction for this, my negative value has to go with the top number. It's never going to go with my r value. It always goes with my other value, not the r. So, sine, let's go ahead. Y over r, so that's going to be?
-4 over, -3.
5, right? Right? Good job. All right, cosine is? Very good. Now, tangent, let's plug it in first. So, what is tangent?
-3 over.
It's y over x.
-4 over.
-4 over. Now, a negative times a negative is a? Okay, a negative divided by a negative has the same rule. So 2 negatives will give you a, 2 negatives is always a, so will I change my answer here? Yes, I will. Because I know that 2 negatives is positive, right? So my answer is going to be a positive. Don't rewrite it, just give me the clean one. Okay.
You want it?
Yes. Man, some people, man, these kids.
I like it.
Don't do it.
I know, except Denny, he's pretty cool. So make sure you change that signs. Now the next one, cosecant would be
5 over -4.
very good. 5 over -4. Secant is going to be
5 over -3.
cotangent is
3 over 4.
-3 over.
-4.
So plug it in first so you don't like lose it in your mind, okay? So you don't lose the negatives. And then 2 negatives again.
3 over 4.
Hey, there we go. You guys feel pretty good about this now?
Yeah.
All right, so don't forget, you guys are going to like, share, and subscribe. Support my channel, buy stuff from my merch store. We just updated some new stuff, so go ahead.